Welcome back, friends. In this lecture, we will discuss about relational calculus. So, relational calculus is an alternate way of formulating the queries. It is a non-procedural query language. The user is concerned with the details of how to obtain the end results. But the relational calculus will tells what to do, but it will not tell how to do. It is based on predicate calculus. A predicate is a true valued function with arguments. On substituting values of arguments, the function result in an expression called a proportion. It can either be true or false. The two types of quantifiers are used in the relational calculus. They are universal and extensional quantifiers. The universal quantifier is denoted by the inverted A, which is read as for all, which means that in a given set of tuples, exactly all tuples satisfy a given condition. The extensional quantifier is denoted by left inverted E, that is read as for all, which means that in a given set of tuples, there is at least one occurrences whose value satisfy a given condition. There are two types of relational calculus. One is tuple relational calculus, another one is domain relational calculus. Tuple relational calculus is a non-procedural query language which is based on finding number of tuple variables, also known as range variable, for which predicate holds true. The notation for tuple relational calculus is mentioned here. Inside the curly braces, we should have T or P of T, or it has been mentioned as T or condition of T, where the T stands for resultant tuple and P of T stands for condition of the tuple, such as equal to, less than, greater than, less than equal to, or greater than or equal to, etc. So we are having two tables here, three tables here. One is loan table, another one is depositor table, another one is borrower table. So for this example, we will be taking the loan table. So for this example, what we are going to identify is we have to find the loan number, branch, and amount of loans greater than or equal to 10,000. So how we can perform the notation here is inside the curly braces, T or T is an element of loan that is greater than the amount, greater than or equal to the amount 10,000. So you can see here, the first T stands for resultant tuple. What the result has to be displayed, that should be mentioned with, that is taken care by this T. So inside this T, we are going to evaluate this condition. Okay. The second T denotes as loan table. So we have to mention the loan details. We have to mention the loan details from this loan table, where the amount should be greater than or equal to 10,000. So you just see the amount is greater than or equal to 10,000 is for the branch name for loan number L33, L35 and L98, that will be displayed. Okay. So this is the first example. And for the next example, what we are going to identify is find the loan number alone for each loan of an amount greater or equal to 10,000. So for this, we are not going to use the universal quantifier. We are going to use only the extensor quantifier here, because we need at least one. Okay, universal quantifier means we will be using A. So here we are going to use the extensional quantifier. So at least one. So find the loan number for each loan of an amount greater or equal to 10,000. So the notation is T or extensional quantifier S is an element of loan of T of loan number equal to S of loan number. That is, amount should be greater than or equal to 10,000. The meaning is the S denotes as loan table. object, which is a temporary variable. Here the extension quantifier denotes only a few table in the loan table will satisfy the condition. So what we are going to do is T of loan number equal to S of loan number denotes the resultant tuple should belong to a loan number attribute. Okay, from the loan table, we are going to concentrate only on the loan number. So where the loan number should be equal to, where the amount greater than or equal to 10,000. So what are all the loan numbers where the amount greater than or equal to 10,000 is L33, L35, L98. That will be displayed. So that is what mentioned here. Okay. So in the this T, that is this T is the resultant T. Inside this resultant T, we are going to evaluate this condition. What the condition is expecting to retrieve only the loan number. Okay. So the left hand side is mentioned that only the loan number is required. Loan number equal to loan number of amount greater than or equal to 10,000. Okay. That's why it displays only the loan number. You can see the previous example. It describes about the loan. Okay, entire table. It describes about the loan of the entire table. So it wants the details of from the loan table. So where the amount is greater than or equal to 10,000. So the entire details means loan number, branch name, amount, everything will be displayed. Okay. So you can see here the next example, what we are going to identify here. Find the name of all the customers who have a loan and an account at the bank. So two conditions are here. One, we have to identify the account holder as well as the loan holder. The meaning is the borrower should be should have the account also. Okay, common. Okay, so two tables has been used here. One is depositor, another one is borrower. Depositor means the person who is having the account in that particular bank, and the borrower means the person who is having the loan account at the particular bank. Okay. So here we will be using the extensal quantifier. So yes, is an element of borrower. T of customer name. We are going to display only the customer name. That is what we require. Find the name of all the customers who have a loan and an account at the bank. Okay. So we want concentrate only on the customer name, where the customer name should have the depositor means he should be the depositor. He should have the account as well as he should have the loan. Okay, that is what we are mentioning here. So yes denotes as loan table object, which is temporary variable. So you see here T of customer name equal to customer name denotes that the resultant tuple should belong to the customer name attribute in the borrower table, and it should be equal to the temporary variable S in the customer name. So here the second T of customer name equal to V of customer name means it denotes the resultant tuple should belong to the customer name attribute in the depositor table and should be equal to a temporary variable V in the customer name. The meaning is the customer name should appear in both the depositor as well as in the borrower table. Okay, the meaning is the customer should have both the account as well as the loan. So that customer will be displayed here. So you see here in the depositor table, Surab is there and Megak is there and Sumati is there. But in the borrower table, only Surab and Megak is there. But Sumati is not there. So commonly Surab and Megak is there. So that will be displayed as the output. Okay. The next thing is the domain relational calculus. So in domain relational calculus, it's a non-procedural query language in which record filter based on domains. The query is based on attributes. So here we are using the set of relations from relation based on the condition. So notation is A1, A2, A3 and AN, or P of A1, A2, A3 and AN. For example, we want to find the loan number, branch, amount of loans greater than or equal to 100. Okay. So here we are having one table, that is loan table. Three attributes are there: loan number, branch name and account. We want both, we want all the loan number, branch and amount of loans greater than or equal to 100. So LBA or LBA is an extensional quantifier of loan greater than A greater than or equal to 100. First, LBA stands for resultant attributes. Okay, this LBA stands for resultant attributes. The second LBA is an extensional quantifier that denotes that LBA attributes belongs to loan table where the amount greater than or equal to 100. So here what we are going to do is we are going to display the details of the loans who are all having the amount greater than 100. Okay, so two persons will be there, two loan numbers will be there, L01 and L02, that will be displayed combinedly. Okay, so the difference between the domain relational calculus is tuple relational calculus is in tuple relational calculus the the data is retrieved based on the value. Here the data is retrieved based on the domain. Okay, and comparing to there we will be mentioning only the T. Here we will be mentioning all the domains what we are going to retrieve. Okay, and the next example, here we want to find the loan number for each loan of an amount greater than or equal to 150. Okay, find the loan number for each loan of an amount greater than or equal to 150. Here L and extensional quantifier BA, LBA is an extensional is an element of loan of amount greater than or equal to 150. The first L stands for resultant attribute. We know that. And extension attribute B comma A denotes that BA also exists along with L. And second, LBA denotes loan is an element of loan that denotes LBA attribute belongs to loan table where amount greater than or equal to 100 stands for attribute condition. The same example only. Previously, we have did for greater than or equal to 100. Here we are doing for greater than or equal to 150. Okay, and the last example is find the name of all customers having a loan at the main branch and find the loan amount. Okay, two tables will be used here. One is loan table, another one is borrower table. Here what we are going to identify name of all the customers having a loan at the main branch. Okay, and find the loan amount. So you see here in the loan table, three attributes are mentioned: loan number, branch name, and amount. In the borrower table, we will be having the customer name and loan number. So the query will be mentioned as C comma A. Then extensional quantifier of L of C comma L is an element of borrower of intersection of extensional quantifier of B of L comma B comma A, extensional element of loan of invert intersection B equal to main. The first C comma A stands for resultant attributes. Then this extensional quantifier L denotes that L also exists along with C in borrower table. Okay. The second C comma L is an element of borrower, denotes that C comma L attribute belongs to the borrower table. The extensional quantifier B denotes that B also exists in loan table where L B comma A is an element of loan, denotes that L comma B comma A attribute belongs to loan table. So where B equal to main stands for attribute condition. So we are extracting the persons who are all belonging from main branch. So who are all the persons belong from the main branch? So here Ritu, Domit and Soumya. So they are belongs to the main branch. So their loan numbers will be mentioned as L01, L08 and L03. You see here L01, L08 and L03 belongs to the main branch and L10 belongs to the sub branch that will not be displayed. So only the main branch customer name will be displayed. So I can understand that you have understood that the concepts of relational calculus and the types of relational calculus, tuple relational calculus, and domain relational calculus are very, very important. I hope you have understood the concept. So we will see in the next lecture. Thank you.